Probability. In earlier classes, we studied about the concept of probability as a measure of uncertainty of various phenomena. In general, to obtain the probability of an event, we find the ratio of the number of outcomes favorable to the event to the total number of equally likely outcomes. This theory of probability is known as classical theory of probability. The probability on the basis of observations and collected data is called statistical approach of probability. Both the theories have some serious difficulties. For instance, these theories cannot be applied to the activities or experiments which have infinite number of outcomes. In classical theory, we assume all the outcomes to be equally likely. Recall that the outcomes are equally likely when all outcomes have equal chance to occur. Another theory of probability was developed by A.N. Kolmogorov, a Russian mathematician, in 1933, called axiomatic approach of probability. To understand this approach, we must know about few basic terms, which random experiment, sample space, events, etc. Random experiments. An experiment is called random experiment if it has more than one possible outcome and it is not possible to predict the outcome in advance. Outcomes. A possible result of a random experiment is called its outcome. Sample space. The set of all possible outcomes of a random experiment is called the sample space associated with the experiment. Sample space is denoted by the symbol capital letter S. Each element of the sample space is called a sample point. In other words, each outcome of the random experiment is also called a sample point. Consider the experiment of rolling a die. The outcomes of this experiment are 1, 2, 3, 4, 5 or 6. If we are interested in the number of dots on the upper face of the die, the set of outcomes set with elements 1, 2, 3, 4, 5, 6 is called the sample space of the experiment. And the elements 1, 2, 3, 4, 5, 6 are called sample points of sample space. Exercise 16.1. In each of the following exercises 1 to 7, describe the sample space for the indicated experiment. Question number 1. A coin is tossed 3 times. Solution. Sample space S is equal to When you toss a coin 3 times, possible outcomes are H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, T, T, T. Second question. A die is thrown 2 times. Solution. Sample space S is equal to, here we are going to get a set of ordered pairs. Chance of getting 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, like that. We'll get 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. How many sample points we are going to get? 36. Third question. A coin is tossed 4 times. Solution. Sample space S is equal to H, 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 T, H, H, T, H, 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 T, T, H, T, H, 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 T, H, T, H, T, T, H, H, T, 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 H, 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 T, H, H, T, T, H, T, H T H T T T T H H T T H T T T T H T T T T. How many sample points we are going to get? 16. Fourth question. A coin is tossed and a die is thrown. Solution. For this, we can draw tree diagram. When you toss a coin, so we'll get either head or tail. Then when you throw a die, then you will get a 1 or 2 or 3 or 4 or 5 or 6. When you get tail, then also you are going to get 1, 2, 3, 4, 5, 6. Therefore, sample space S is equal to H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. Fifth question. A coin is tossed and then a die is rolled only in case a head is shown on the coin. Solution. Sample space S is equal to, when head occurs on the coin, we have to roll a die. So there is a chance of getting 1 H2, H3, H4, H5, H6. Then there is chance of getting a T on the coin. Sixth one. 2 boys and 2 girls are in room X and 1 boy and 3 girls are in room Y. Specify the sample space for the experiment in which a room is selected and then a person. Solution. Sample space S is equal to, first we have to select room X, boy 1, room X, boy 2, room X, girl 1, room X, girl 2, room Y, boy 3, room Y, girl 3, room Y, girl 4, room Y, fifth girl. Eighth question. An experiment consists of recording boy-girl composition of families with 2 children. First one, what is the sample space if we are interested in knowing whether it is a boy or girl in the order of their births? Solution. Sample space S is equal to boy, 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 girl, girl, boy, girl, girl. Second one, what is the sample space if we are interested in the number of girls in the family? Solution. Sample space H is equal to chance of having no girls, 1 girl, 2 girls. Question number 10. An experiment consists of tossing a coin and then throwing it second time if a head occurs. If a tail occurs on the first toss, then a die is rolled once. Find the sample space. Solution. Sample space S is equal to when head occurs, then second time coin is thrown, H, H, T. When tail occurs on the first toss, die is thrown, T1, T2, T3, T4, T5, T6. Question number 12. A coin is tossed. If the outcome is a head, a die is thrown. If the die shows up an even number, the die is thrown again. What is the sample space for the experiment? Solution. Let us draw tree diagram. When coin shows head, Die is thrown. 1, 2, 3, 4, 5, 6, tail. When a die shows even number, again we can throw die. So sample space S is equal to H1, H21, H22, H23, H24, H25, H26, H3, H41, H42, H43, H44, H45, H46, H5, H61, H62, H63, H64, H65, H66, then T.